thanks to Iliauni, become members of IEEE recently, and we are founding the student branch. So that's a very good news from you as well, and confirmation that this organization is valuable for us. Now I'll switch to the next speaker. I'll switch for a bit in Georgian to introduce the next speaker. დიდი მადლობა ყველას ყურადღებისთვის და მოსმენისთვის. ჩვენი შემდეგი სტუმარი არის Ulrich Hauser-Ehninger, პროფესორი, დოქტორი, ელექტრონული ინჟინერიის მაგისტრის ხარისხი გრისონების გამოყენებითი მეცნიერების უნივერსიტეტიდან. ეს უნივერსიტეტი გახლავთ შვეიცარიაში, ქალაქ ჩურში და ჩვენი სასაუბრო თემა იქნება MQTT, როგორც IoT პროტოკოლის შესავალი და პროფესორი ულრიხი ამ პრეზენტაციას გაამდიდრებს თავისი პრაქტიკული მაგალითებით. მოგახსენებთ ულრიხის შესახებ, რომ მან ბაკალავრიატი სამედიცინო ინჟინერიაში დაასრულა, შემდეგ მიიღო მაგისტრის ხარისხი ელექტრონულ ინჟინერიაში ველსში და შემდეგ მიენიჭა დოქტორის ხარისხი ელექტრონულ ინჟინერიაში, ასევე გაიარა ველსში, კარდიფში. დოქტორანტურის შემდეგ პროფესორი ულრიხი მუშაობდა ჰამილტონის სამედიცინო უნივერსიტეტში, რომლის მიზანი იყო ინტენსიური თერაპიისთვის სუნთქვის აპარატების შემუშავება და 12 წელია იგი უკვე ასწავლის გრისონების უნივერსიტეტში და 2019 წელს, როგორც აქამდე ვახსენე, ის სტუმრობდა და იყო ილია სახელმწიფო უნივერსიტეტის მოწვეული ლექტორი. Now I will switch to English again. Our next speaker will be Professor Ulrich Hauser, and the topic for today will be introduction to MQTT as an IoT protocol, and Professor Ulrich will reach up the presentation with the practical examples. I will say shortly that Professor Ulrich was the invited lecturer at Ilias State University in 2019, and he holds PhD in electrical engineering, and he used to for 12 years, he now works and teaches at in the University of Switzerland. And I will give the stage to Negar again and wish you good luck with the presentation and Q&A session.
Okay, thank you, Tico, again. Okay, so hi, Ulrich. I can't see you here. Oh, okay, I can see you now. Okay, so Ulrich was my professor, actually, I think 2 semesters ago. I learned IoT from him. So I'm really glad that you're here, Ulrich.
Hello.
Hello. Can you introduce yourselves in your own words?
Yes, actually, that's part of the presentation already. So that would be covered by one of the first slides.
Let's get right into it, I guess, then.
Okay. So we don't wait until it's 6 o'clock. For me, it's 6 o'clock. For you, it's 8 o'clock.
Yeah, I think we can start because everyone is here already.
Okay. So I shove this picture a bit aside, which makes me looking funny because my position is not directly at the camera. And then I will change to the next screen. You should be able to see this screen now.
Yes, we can.
Good. So I think we can start with MQTT as an IoT protocol together with examples. For the examples, I've got a little machine here, a Raspberry Pi, which will be introduced during the presentation as well. So you will see some live action of communicating through MQTT and other protocols. Can you understand me good enough? So is the acoustics okay?
Yes.
Okay, good. So shortly about me, in chronological order, I grew up in a small village in Germany where I attended primary school, and my secondary school then was with a special focus on music and science, which I think is a great combination. I carried on with aeronautical engineering and then changed to medical engineering to finish with a Bachelor of Science, and carried on after a bit of research to electronic engineering in Cardiff, where I did a master's, and later on I did a PhD. My experience, as I said, is a bit of research in the medical area, which was non-invasive brain pressure measurements, very interesting. Then I worked as a freelancer, writing software testing systems, joined a tech company, small, middle-sized, with hardware and embedded systems, and then for a change worked with a really big company you probably know in Georgia as well, because they work on a worldwide basis. There I again wrote testing system, this time for mobile phones. After my PhD, I joined Hamilton Medical, which is a company which develops not only, but for me, developed ventilators for intensive care. And as the introductory person Tico said, I'm now a lecturer at the FHGR, which is a university for polytechnical stuff, electronics and software development. I wanted to thank you both for the invitation, Tico and Nega. Actually, Nega was the one who grabbed me by the neck and dragged me into that.
Oh, come on.
So, so I'm quite thankful for that. I hope it will be a fun session. So to dive into it, I will show you what I plan to confront you with this session. First, what I assume you to know, because obviously the people listening could be from quite different contexts. So I have to set some stage. Then what it is all about IoT. Nega asked me to do a quick and short introduction to the IoT as in general as well. Then I need to do some knowledge preparation, which means I don't dive into MQTT directly, but I show some of the principles which lead to MQTT, which will be things like polling versus message-driven programming, WebSockets, together with an example. And then I will go into the MQTT architectural overview and finish up with some examples where you can participate, even to view the communication on your computers. I hope that will work out for you. And so we'll start with what you should have knowledge of to be able to follow. You should have knowledge about a programming language, preferable JavaScript, because obviously a lot of the IoT stuff is programmed in JavaScript. A lot of the internet is programmed in JavaScript. And JavaScript works principally in a way which is very favorable for the IoT, which we will see later. Then I assume you have a basic idea about the TCP/IP stack with IP addresses, ports, and sockets. And I assume you know about HTML and HTTP basics. As a kind of introduction, I want to cite Mark Weiser. He wrote a long article in 1991, The Computer for the 21st Century. And there's the sentence, "The most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until they are indistinguishable from it." If you look at the main computers you see today, I think there is still a lot of improvement and a lot of potential to make them disappear. Because if I look at my desk here, I can find a lot of computers directly. I've got a laptop in front of me, which is obviously a computer. I've got a mobile phone, which has a performance which 20 years ago would have served possibly a complete university, and so on and so on. But if I look at the usability of these computers, I sometimes am quite disappointed that we have this kind of performance like in a mobile phone, and still they are not really able to support us in a way where they are vanishing. Just the contrary. How many of us spend hours and hours a day on the mobile phone, being eaten up by the mobile phone, which is not the way I think electronics is kind of weaving itself into the fabric of everyday life until it is indistinguishable from it. So I think there's a lot to be done in this field to make these devices disappear and just do their job. Now, the IoT can be introduced using something like this. A lot of devices nowadays have their intelligence, and both sides of the coins are shown here in a small cartoon. There's a positive side, possibly, which is slightly indicated on the left, but an even worse side on the right. So these devices spread all over our houses, trying to solve our problems, trying to help us solve our problems. These devices have some intelligence, they have connections, but everything with intelligence and connections is vulnerable. Possibly some of you know about webcams being used for distributed denial of service attacks, which is one of the extreme examples of the right part of this cartoon. So for everybody who is meddling with IoT devices in a professional way, so that quite big numbers of devices are rolled out, need to take care and have always in their mind that IoT has big issues with safety and security. Don't forget about that. Now, what is the IoT? Quick definition. The Internet of Things is a system of physical objects, so something really existent, that can be discovered, monitored, controlled, or interacted with by electronic devices that communicate over various networking interfaces and eventually can be connected to the wider internet. So basically, in this definition, humans are not there, which means that the communication in the IoT is mainly machine to machine. What we see at the end are just the user interfaces to set the global things which are connected to IoT networks and IoT systems. But generally, most of the communication is done machine to machine. And this is quite a difference to what is normally done in the internet with browsers and so on. The IoT, the Internet of Things, obviously talks about things. And things are normally their smart things, obviously, because a dumb thing can't be part of the IoT, because it needs to be able to talk. It needs normally have one or more of the following: sensors, so eyes or ears or noses or whatever kind of information can be collected by such a thing. Actuators, possibly lights, magnets, motors, they can control huge systems. Computation, obviously, because otherwise it would not be a smart thing, but a dumb thing. And communication interfaces, which is obvious as well, because otherwise these devices couldn't talk to anybody. Where do we find IoT? Obviously in our homes, but we find it in smart factories. where more and more of these autonomous networks are installed and are working. Advanced robotics, smart homes and home security, obviously, smart diagnostics and maintenance, smart energy, smart tourism, and sport and health improvements. Now, the IoT, as we know it, can be divided into several levels of IoT, let's say, intelligence. First, we might have a thing like this Raspberry Pi, which would be programmed directly without network, no sensors and actors. No, sensors and actors are controlled directly. So which means this machine will control all the sensors and all the actors which are connected to it by the intelligence which is on this machine itself, which more or less is the definition of an embedded system and not something which is networked. So this is kind of level 0. From here on, I will keep to an example, which could be a coffee machine. A coffee machine without connection. You need to look after it. You need to look if there is enough water, is there enough coffee, and you have to fill it up by yourself. The next level would then be things which are connected locally. So it could be that this coffee machine is kind of connected, but it doesn't really talk much. So this is a kind of level where you are, where these devices know about each other, but there's not much intelligence in it. In the next level, the coffee machine will have sensors, and they, for example, could tell a locally connected phone about its state. So if you're close to this coffee machine and you are possibly employee in a company with this coffee machine responsible for this, then the coffee machine could connect you, or you could connect to the coffee machine and look remotely if it is still enough water, and so on and so on. But that's not the thing which is interesting and good for us, because we have to look into more. We want to have these locally connected things connected to the World Wide Web, because otherwise we are locally too much restricted. And this obviously then opens up possibilities for this coffee machine to do a lot more, because if we now have the coffee machine connect to a database which could know about user habits and patterns, let's say the coffee machine is in a company, then it could proactively estimate when refilling will be necessary, and the coffee machine itself could order the goods. If there are events, possibly the coffee machine is in front of a big hall, then the machine should know about this and could behave accordingly, which means it could fill up a bit earlier than normally, because many people would be expected to come. This is the real internet then, because without much human intervention, this machine will do its job, knowing about other machines, knowing about people around it, and reacting to these people accordingly. So this is a very short and quick introduction to the Internet of Things. I left out a lot of stuff which are obstacles which could help in developing or further developing the IoT, like standards, like the Web of Things, which is a huge expression at the moment as well. And so this is really very brief. And I will now try to dive into the technicalities, which means we have to look at why is MQTT such a prominent protocol in IoT. When you imagine there is a remote sensor working on batteries, it could be something very small, something which shouldn't take any current or shouldn't take much current. and we look at how embedded systems for long years normally worked, then you can see we have got a main function, and this main function is running around in a loop, which means it goes to one task it should normally do and asks, do you have some work for me? The task says no, and the main goes to the next. These tasks are normally functions which are called by main. Then it again asks the next task, do you have work for me? Again, there might be a no. At the third task, there might be a yes, and then this third task will be executed for a while until it finishes. And after that, the main function will ask for the next task, and it will ask for the next task. And when it has asked all the tasks, it will return to the first task and start from the beginning again. Which means the main function on this processor is running around in circles and running and running and running and never stops. There's obviously a big disadvantage to that. This system wastes energy because most of the time it doesn't do anything. It just doesn't do anything. Because main is just running around and getting no, no, no from each of the tasks it normally should do. So this way is not a good way to drive sensors to save energy. There is a different way. And this way means main is sleeping. And sleeping and sleeping until possibly one task says, oh, I have work to do. And then main will execute this task. And when the task is done, main will go back to sleep, which obviously is much more energy efficient. Why? Modern processors are able to shut down when they don't have to do anything. And these tasks might be connected to external sources, let's say to sensors without much intelligence or other stuff, and they will be notified when something interesting happens. So this task will notify the main when there is something to do, which kind of is an inversion of what we've seen before. Before, main had asked all the tasks if they have anything to do, and now the task just says, hey, wake up, boy, I have work to be done. And all the other time, the boy is allowed to sleep. The second way is the way that, for example, modern user interfaces, JavaScript, or, as we will see later, MQTT works. For a first example, a lot of you might know, I want to have a look at the JavaScript engine to see what I meant with the slide before. The JavaScript engine, in my view, in my model, looks like a mailbox with a dog sleeping. Then suddenly somebody drops a message in the mailbox and the dog wakes up and picks out the message and looks on the message and starts to run around to find out, oh, which function do I have to do? What is the meaning of the message? And it will find the message says you have to call function number 3. So the dog executes function number 3, which might involve a function which is called setTimeout. This setTimeout in JavaScript is a special function which will call an alarm clock. So it will call the alarm clock and say, please set yourself and ring in about 3 seconds. It could be 3 milliseconds as well. It doesn't matter. It will just say, please ring in 3 milliseconds. And this function could do other stuff as well. But at one time, this function is done and the dog is sleeping again. And after some time, let's say these 3 milliseconds, the alarm clock rings and it generates a message. This message is dropped in the mailbox, so the dog wakes up. The dog wakes up, picks out the message from the mailbox and starts running again. This time the message says, oh, there's a function number 1 to be executed. So the dog will execute the function number 1. But there might be even more functions, which is depicted here by function 2, for example. And if you look at complex web pages, you will find that there are dozens and dozens or even up to hundreds of these functions, which are called upon messages coming in, and they will be very, very quickly executed. And after the execution, the dog will again go to sleep. So JavaScript as an engine works kind of exactly like I described in the previous slide. You have something which could save a lot of energy with the dog sleeping, and only when it's necessary wakes up. Now, let's put this into context with another thing, which is HTTP for me. HTTP is a major communication mechanism for web pages, for browsers. And with HTTP, it is always the case that you have a client-server connection, and it's just a request, and this request will create a response, and that's it. So if the client wants to know something from the server, it is no problem, because it just asks and the server gives the answer. But what if the server is an IoT device with a sensor? And the sensor recognizes that some measurement value has changed and the client needs to be notified by that. Then we are kind of in deep trouble, aren't we? Because this is, again, energy waste. Because if the client wants to be updated regularly, it needs to poll the server. So it needs to ask with a request and again ask with a request and again ask with a request and never stop. And so the server could never sleep because it will be always asked. So this is not really a solution. Not from the IoT point of view, where energy is all. No, but there is a solution to that problem, which is in the standards since HTML5. And this is WebSockets. What do WebSockets do? WebSockets keep a connection open between the client and the server. And through this connection, the server is able to talk directly to the client without being asked by the client. This obviously saves a lot of energy. Now, what does this WebSocket bring? We could have a sensor, and this sensor gives a new measurement value to the server. This all could be in one IoT device. Not necessarily, but it could. And then the server is allowed or able to notify the client through standard web technologies. This is important, through standard web technologies, because we want to stick to web technologies as far as possible. So this is a complete difference. This is really, really new in HTML5. And this is a breakthrough for HTML5 being possible to be used very efficiently in the IoT area. I want to show you a setup which consists of my laptop and a Raspberry Pi. This Raspberry Pi should be written with 2 R's at the end, I guess. I just saw that. The laptop has a Linux VM. Negar knows that I never go without a Linux VM.
Yes.
On this Linux VM, there's a Websocket client, and on the Raspberry Pi, we've got a Websocket server. And the Websocket client will set up a connection to the WebSocket server. The WebSocket server will answer, and that means we have a connection with web technologies, and I want to show you this just now. That's my screensaver of the virtual machine. And now, let's just set up the server, which says I've got a WebSocket created on port 8081, and I fire up a client, and this client connects, and we see the connection has been set up, and the client talks, but the server is allowed to talk as well, as you can see. So we have the client which opened a connection, which is acknowledged here. And suddenly, immediately, the server talks and sends a message, whatever, to the client. So this is the first communication from the server to the client without the client really asking, because the only thing what the client did was open a connection. And opening a connection is not asking. And later on, the client talks to the server a couple of times, which is from 0 to 3 here. And then the server is triggered. This is done actually using the set timeout routine I've showed you a couple of slides before. And the server talks again without being asked, and the client sees that the server talks to the client. And again, until the client closes the connection, which is acknowledged here. So this is a very, very simple example for a WebSocket. And if you look at it, you will realize that this is not much difference to just a normal socket connection. It could be just a plain TCP socket, which is opened here. There's not much difference. Under the hood, there is some difference, but the concept you should keep in mind is exactly the same as the one with TCP sockets. So if you think about WebSockets being kind of like TCP sockets, you are quite on the right track. Okay, so this is my first scenario. I want to do a second scenario because actually this server here is not really a web browser, is it? And so I want to do a second scenario, and I want to show you this second scenario. But this second scenario has a different setup. It again has my laptop and a Raspberry Pi. Again, a Raspberry Pi with only 1 R. And a Linux VM. But now I've got a web browser in the Linux VM and in the laptop itself, which runs under Windows. And we have a web server on the Pi and a WebSocket server on the Pi, which runs on a different port number. Keep that in mind. So this is a completely different setup. And I want to show you the concept as well, which means, like with a standard web page, the web browser in the Linux VM, or never mind in the web browser on Windows, it will issue a request for a web page and we'll get this web page back. This web page might have more files to be dragged afterwards, like the JavaScript file, which later on will build up our WebSocket connection. But like a normal standard web server, we will get our files with a request and response in HTTP. And then when the web page is active and running the JavaScript, then this will open a WebSocket to talk between the web browser and the WebSocket itself. And this looks quite differently to what we saw before. So this is my second setup. I've got a browser open here. I've got a web server which will be started from there, and the WebSocket server from here, and both are not running at the moment. So if I now try to get the page, I get nothing, obviously. Then I start the web server, and if I now get the page, I get a page. And I have to say, somewhere else there seems to be still this WebSocket server running. I don't know where. Ah, I know. I haven't stopped the servers here, did I? Here, I haven't stopped that one. So if I now get it back, I get an error. Sorry, I didn't stop the WebSocket server before. Now, I get a web page, but I don't get anything over the WebSocket server because the WebSocket server needs, obviously, to be started. Now the WebSocket is running on port 8081, and I can get the web page a third time. And now you can see that I've got a WebSocket open, because without doing anything on the web page, this WebSocket server just pushes communication from the WebSocket server to the web page itself, which means now a website like the one which is open here in this browser, such a website can be notified by changes without asking, which means this website is kind of passive for the moment, but it will not be but although it is passive, it will not be silent, because it is notified by the WebSocket that something happens, and it will then wake up, show what happened, and then go to sleep again. Obviously, this is a very simple example without much usage, but I think it shows the principle pretty well. So now, if I stop this server again, you see that the connection is closed down. And if I now again reload the web page, I get the error again, because the page itself is not able to open the WebSocket, obviously because the server doesn't run anymore. And if I shut down the server itself and I get the web page, you can see that the web page can't be fetched again. Which means you now have seen a web server kind of live in action, a WebSocket server live in action. So this principle helps us with IoT. Keep in mind, energy is everything. The web page could sleep, but the WebSocket server could sleep as well, as long until some sensor says, hey, WebSocket server, please wake up. I've got new measurement values for you. Please send them to the web page. So everything is much, much more efficient, and with just very, very small amounts of communication. And obviously communication is energy as well. So I will go back to the presentation now and finally start to get into MQTT. Now, MQTT is the same principle like a WebSocket. So we have notifications, but there is a huge pattern around it. I will show the basic pattern first. MQTT always has a message broker, which is kind of the central part of it. And this message broker can manage so-called topics at channels. Such a topic looks like something like that. So you have got a string with parts which are separated by slashes. You will see it in an example later on by yourself. And so we have more topics, obviously, because if there's only one topic, there wouldn't be much to manage, and we can have more than one topic. But let's forget about these for now. We've got a client, and this client says, I am interested in this topic, so I want to subscribe. Then this client will be notified, as we will see later, but we need something else which will generate messages for this topic. So we have possibly some other client to this message broker, and this client generates messages, which is called publishing. So we have got one entity which publishes. After this client has subscribed, the message broker will issue all the messages which are sent by the client 1 to the client 5. This is a huge improvement over a WebSocket. Why? Because client 1 does not need to know anything about client 5 and vice versa. So the clients are completely decoupled because the management is completely done by the MQTT broker. What's the advantage of that? Because that looks much, much more complicated than before. The advantage is that we could have something like another topic with more than one client being interested in it. So again, we will have another client which produces messages, and these messages will be issued to all the clients. And this is not possible by simply using a single WebSocket. So when client 2 uses one WebSocket to communicate to the message broker, the message broker itself, which is a complex piece of software, will use WebSockets possibly to communicate with these clients. It's not necessarily WebSockets though. So the MQTT protocol itself is independent of from WebSockets. I didn't point this out properly possibly, but the MQTT protocol itself does not need any WebSockets. It's a protocol by itself. Now, there are even more complicated scenarios. We can have more than one client generating messages, which would just result in the messages being still given to all the clients. So all the messages will be given to all the clients. We can have more than one subscription. We can have more than one topic, and we can have a client which itself issues messages to possibly another topic. It could be this topic as well, it doesn't matter. And so you can see we get a very, very complicated thing which can issue messages all over the place and which can subscribe for topics all over the place. So this MQTT allows us to make the system incredibly complex without losing control. So this is the main part, the core of MQTT. It's the principle of MQTT. I don't want to go too much into technical details in this talk, but I want to show you some of the communication characteristics. There's a very small footprint because the header of these packages is only 2 bytes big. It is connection based, so a connection is opened up and held open, and over this open connection, the communication takes place. The client always starts the connection. So one of the big problems of clients behind network address translation devices is vanishing, because once the client behind a net starts the connection, it is no problem for the NAT to do all the communication work. So even clients behind nets are no problem for MQTT. Very important. It is session-based with good security features, so all the actual security is supported. I don't want to go into that. Quality of service features are there. So there are a couple of levels for quality of service, which could say, I don't mind if the message doesn't reach any recipients. Or it could mean, I don't mind if the message is received multiple times. Or I want to be sure that a message just and exactly reaches a recipient once. So there are different levels of reliability, which are applicable to different requirements. So if you've got just temperature measurements and a temperature measurement is lost, in most cases, this doesn't matter too much. The next measurement will compensate for that. But if you have got actors, so if you need to control a motor or stuff like that, it is often very, very important that a message definitely reaches the recipient and reaches the recipient exactly once. The messages are typed. So they are typed by giving different targets, like the topics. And these subjects are in hierarchical order. This is a topic consists of a string with separated fields which are separated by slashes. You will see this in action later on, so I think it will be clear after all. And the payload format officially is free and open, so you can send whatever payload you like to, but very, very often JSON is used because JSON is a very compact format using not too much overhead. A sample conversation. Let's say a client wants to connect to the broker and is accepted. And then there is a client B, which publishes some measurement with some additional information, which means retain, please retain, which means if somebody subscribes, which is that one, then please send the measurement to this as well. This client A could now publish information about the floor temperature. So this client A is a subscriber and a publisher in one device. And then this publisher, which is client B, sitting possibly on the roof, publishes its new temperature. And then client A says, oh, I'm not interested anymore, and I disconnect. This could be a sample communication using from connect to disconnect, client A and the broker. I want to show you this kind of communication with, again, a demo setup. And I use an open source, an openly available MQTT broker, which sits on the internet. So if you go to this address, if you type in this link, you can take part in what I do next. So don't hesitate to hack into your browser, and I'll show you the setup in the meantime. I've got, again, my Linux virtual machine with an MQTT subscriber, And I've got the Raspberry Pi, which is the publisher, which is normally the case because the Pi normally would be the IoT device. And I've got the MQTT broker in the cloud. Then the VM will subscribe to the MQTT broker. And afterwards, the Raspberry Pi will publish to the MQTT broker. And this published information will then be published to the MQTT subscriber in the virtual machine. And you will be able to see the communication on the way, even if you like, on your own computer. If you hack in this URL and you enter this host address, then you can connect. Obviously, I took the screenshots while being connected, but if you enter this, then you just could hack in and say, I'm connected. Then you will see something like this. You can now add new topic subscriptions. And I would ask you to add something which is called Hauser/state. This is some topic. And again, add one more, which is called Hauser LED. Beware, when you enter a new topic, don't hit enter, but really hit the button, because otherwise you might be thrown out of the connection. This happened to me a number of times. Okay. So I now want to show you this scenario. You can see I've got it set up like that already. And I want to connect to this broker, add a subscription, and add another subscription. No state, I think it is state, yes. And you see nothing happens. But now I start my publisher. Which is a program which can analyze what is going on the Raspberry Pi. I will show you that for the moment. So I'll quit the screen. How do I quit here? The screen like that, I think. Yes. So you can see this is this Raspberry Pi. And if you've got your system running now, and if you have the your web page running, and I've now pressed this button, you should see a new message popping up on your web page. Now, okay, I press, and you should see the state coming through on your web page. I can do this with all the buttons, and you can see while I press, the status on your web page changes. So that is just the MQTT broker for the moment. And to show you the rest, I need to go back. So you just believe me that it's about pressing the buttons. I need to get back to the screen again, which is this one. And if I now activate my my subscriber, which is active now here, and I again press buttons, my virtual machine shows the state change. And this is a message which comes through. This is switch 3.0. This is what you can see here as well. But what is this publish here? This is a thing in the MQTT broker, which is offered by this web page, where you can publish on some topics. So now, if I say, for example, I want to publish this message on Hauser-LED, then you will see that this Hauser-LED is notified on my virtual machine. But it's not only that. I now switch back to the video, just a moment. And you can see that an LED went on. And now I give again 3.0 and publish it, and the LED switches off. And now, and that is the end of my presentation, I invite you to play with that. So try to publish something on your machine and try to find out if you really could have an effect on my Raspberry Pi. So I think we'll have another 2 or 3 minutes for that, so that we end at 6:45, or for you it's 8:45, I think. So try to put in a message in the topic I've shown you, and try to make my LEDs switch on and off. No success.
Could you share your screen again, please, of the website? And
okay, no problem. No problem, yes. That was Sarah, wasn't it? Ah, yeah, haven't seen you for a long time.
Yes.
Okay. Just a moment. I have to switch back to the screen. You want to enter the correct values, I guess. Actually, the topic is Hauser/LED. It's the same topic as you have here. And the format is a plain JSON with just 2 integers in it. So the first one is the number of the LED. And the second one, if it's 0, it switches the LED off. And if it is a 1, it switches the LED on. So, and I hope this information is enough. And I'll switch back to the camera and wait if anybody of your, if somebody from your side can be successfully switching on my LEDs. None yet?
The thing is, we have to sign up for the Hive MQ.
No.
Oh,
Not
really?
necessarily. I didn't have to sign up. I just went there. I never made any. Do you have the correct link? I'll go back to the. I would be very surprised if you need to go, if you need to subscribe, because I never subscribed. So did you have the correct URL? This is the URL you should use.
Is it possible to
Okay.
copy the
Could
URL
you,
in the chat?
yes.
Yes, just a moment. There is my chat, there is my chat, there is my chat, there is my chat. I can't write to it. I'll just stop the video because then I can really write into the chat. It's strange that I can't write into the chat like that. So now you should have the link. And I'll show you just for a moment the screen again, so you can enter the proper values. But you should be able to get on this side because, as I said,
Yes.
something
Now
happened. Somebody sent an empty message, but somebody sent a message. I can see that because you could see that here as well. Somebody sent an empty message. So, that looks nice. This switched off my LED number 3, which was off already. Now try to switch it on. A 3 doesn't help. You should be able to. I don't know why you don't reach me on the Raspberry Pi, because this reached the Raspberry Pi, obviously. This one issued an error. My server issued an error because somebody sent me the wrong packages. Now, if you now try to send correct packages, it should be all right. Because the server breaks when you issue messages which are not understood. If you try to, let's say, send LED 1 should switch on, which means 1,1 in the JSON, then you should be able to switch it on. Yes, that was it. Yes, now the people try. So you can see from Tbilisi or wherever you are on the planet, you can switch on my LEDs. This is cool, isn't it?
It is amazing.
So there we are. I think you were successfully hacking my machine, and I think I'm finished with my presentation. And so I think I'm open for questions now.
Okay, first of all, thank you. That was really cool. I just wanted to say, like, you're probably one of the best professors I've ever had. So yeah. So that was
Agreed.
Yeah. So let's do questions. The first question that we have is, what advice would you have for students who are learning or thinking to choose computer engineering as their career?
Be curious. Don't have fear from playing around. Don't have regrets when you light up a Raspberry Pi in smoke. So you have to play. You have to make errors. You have to destroy stuff while learning stuff. But just keep interested. Keep playing around, and try to find out how things work.
Okay, that was great.
There's a lot of the stuff I learned, I didn't learn at university. No, I played around with a lot of stuff, and I learned many things just by doing it myself, even the things I teach. Just meddle with this stuff.
That explains why you teach so well, because you kind of discovered things by yourself. Okay. So, the second, Ahmed is like, I hear the motivation music in the background. Thank you.
What,
okay.
Motivation music?
Yeah, like what you said was really motivating. So, yeah. Okay. So the second question is, are you working on any innovation in your field? Basically, are you innovating anything in your field?
At the moment, I actually do, yes. I do. I've got a very interesting project at the moment, which deals with toys again, which are model gliders, so sailplanes, which normally are controlled by radio transmitters, and for different reasons, it is very interesting to make them autonomous. So we are at the moment building a plane, a model air glider of quite some, let's say, some size. It's about nearly 5 meters across, which is a bit away from having a toy, but it's still considered a toy. And we will stuff a lot of electronics in it, pressure sensors, GPS. What's the English expression? Movement sensors.
Yeah, that's a thing.
Then temperature sensors, and so on. And then we'll measure that during flight. And when the plane starts to find some thermals or some uprising air, it will try to stay in there. So it should be possible to build a sailplane which can fly autonomously for nearly indefinite time, because obviously flying a glider is very energy efficient. And an additional thing is it is very silent. And applications of that can be two things. First, you can go into, how do you say, national nature reserves. Is that the right word? You could fly into nature reserves without disturbing the animals and still
Yes.
have surveillance of these areas. Because actually here in Switzerland we have got a quite big area which is not possible to go in with any machines. And with this kind of silent glider, you could in there and let's say count the animals and stuff like that. You could set a GPS fence around this area and have the glider staying inside there, or you could say fly along that path as long as possible. And if the altitude is too low, the glider should find again rising air, making height, and then again follow the path which was given to it. And a second application could be transport of goods in a very efficient way, which is far, far, far in the future, obviously. But there are lots of goods which are not really essential to be delivered in a very specific point of time. And I'm pretty sure with these gliders, we could be even faster than the boats on the ocean to go, let's say, from China to Europe. So if you've got autonomous gliders, you could transport goods in a very energy efficient way. And there is a project actually going on at the moment mostly in South America. They are flying with a glider to look how high you can get with such a glider. And they went over, I think, 24,000 meters now. So which is far, far, far above anything which is done by the normal traffic, air traffic and passenger traffic. So it should be possible to stay out of the way of all the polluted spaces. So this is possibly the most interesting project I worked on for all my time.
That's really huge. Yeah, okay. Let me see. Okay, we have another question that why do you use Linux? What's so good about it?
It is stable.
Okay.
It is quite complicated, but you can do everything you like with it if you dive deep enough into it. And obviously, you can earn money with Linux. I think that is proven widely enough now. Although Linux itself is an open system, and you can strip it down to very, very small systems. As far as I know, Windows fight it for quite some time to pack itself onto a Raspberry Pi, and only the newer Raspberry Pis were able to hold a Windows. And there are less restrictions, so I can do a lot of stuff which I won't be allowed to do on a Windows system. So these are the main reasons. One of the things I love on Linux is the console, the terminal, which is quite okay in the last Windows versions now as well, because they kind of adopted the Linux style and implemented this into the Windows, which I think is one of the indications that Linux has its advantages, which doesn't mean that Windows is not acceptable for me. I use Windows, for example, for presentations, because I think there is no Linux equivalent for PowerPoint. Especially you have seen, I worked with quite a lot of animations, and these animations are, I think at the moment, nearly impossible on Linux.
Okay, so basically it's flexibility and stability are the main two reasons.
Yes,
okay.
Definitely.
And another question is, what would you recommend for someone who is trying to step into the world of IoT? So how do they start? What is the starting point?
Get yourself a Raspberry Pi and play around with it. That's one of the intro steps, I would say. And the second thing, for that, I have to show a web page. Just a moment. which is this one. This is called the Things Network. And this is a collection of LoRa.
Could you share your screen, please?
Sorry. Now, yes. Sorry, I missed one button. This is the so-called the Things Network. This is a community, and they collect LoRaWAN gateways, which are antennas with a certain standard for radio transmission. LoRa is a very low energy but slow connection, and there are plenty of these around the world. This is a world map of LoRaWAN, and if we look, for example, you can see that in Switzerland we have about 1,000. We have about 1,000 of these. And if we go a bit further on, there is a small country, I think it's called Georgia. It's about the same size as Switzerland. And if I'm correct, I think even in Georgia there is one of these gateways, and surprise, surprise, this gateway is somewhere in a city you might know.
In Tbilisi.
It's in
So it's there above, up the hill, somewhere on above the lake,
yeah.
which is a good position because they are high frequency, so they depend mainly on line of sight. So high altitudes are good, but the distance from here to here should be okay if it is a line of sight. At our school, we have bridge distances up to 40 kilometers with this, so this should be okay. But if Nana is listening in at the moment, I really would motivate her, or try to motivate her, to join the TTN. Our school is pushing this as well. So you could possibly put one of the gateways here. I think I know this region roughly, somewhere there, or possibly another one up the hill here. Because if you look back to where I am, and we go in again, a bit further on, this is my country. Now we get closer to where I live. And this is my school. Even our school has two. That is one on the roof here on the main building, and one in the laboratory, which is an indoor gateway, and another one on another part of the school. And then there is a small village from where I talk at the moment, which is a bit away. And there is another of these. And I can tell you that I talk from this house.
So there's one exactly in your house.
So there is one on the roof of my house, but that was paid by the university as well. Mm-hmm. So I just said I offer to put it on my roof. And in the next village, there's another employee of this school.
We can stop here now.
Which is here. I think we can stop here now, yes. But this is, I think this transmission standard is going places, definitely. And there are nodes available for with this radio technology, which can be put to sleep with less than 1 nanoamp consumption during deep sleep. So you could have these devices sleep for hours and days on very small batteries, then wake up, measure something, send the stuff over to the TTN, and go to sleep again and live on a single battery for up to 10 years. And I, with my students, now work with these nodes, so I don't work with PIs anymore, because we can use this TTN all over the place. My students are, especially at the moment when the university is closed, they are distributed over half of Switzerland, but all of them could connect to one of the TTN gateways. So they are working on a project now, but all sitting at different places, but they can join their data because everybody can connect to some of these LoRa gateways. And this is the place to go. This is the activity. Just be curious, try to play with that stuff.
Okay, so yeah, I'll for everyone who's watching on Facebook, I will send email like after the event is over, and I'll give you guys everything that is here. Okay, one last question. So, when are you coming back to Georgia?
I can't at the moment.
Yeah.
First of all, I can't at the moment. When I came to Georgia to teach, it was a so-called sabbatical for us, and I'm allowed to do a sabbatical all 10 years. So I guess when I come back, possibly to teach in Georgia, none of you will be students there anymore. But on the other hand, when I look at how teaching and how universities develop, especially now in the pandemic, I think teaching without being there will become more and more common. So I don't see there's much difference in me teaching you at the moment, or with this presentation, or me teaching my students just 10 kilometers away at the university, because they are distributed as well. So I think the difference is not really big. So I'm pretty sure that the development in teaching, even when the pandemic is over, will more and more be kind of remote and with experts teaching wherever it is necessary without going there. So there might be a possibility that I teach in Tbilisi without being there.
Oh, so are you working on it?
I think he's proposing. I think he's proposing this right now. But yeah, that would be great, actually. I think a lot of people can use your knowledge and stuff.
No, I'm not working on that at the moment, because actually I would like to come back to Tbilisi, to Georgia. I definitely would like to climb Kazbek. That is on my list. I definitely want to get up there because that is a magnificent mountain.
Okay.
So even if I'm not coming for work, I'm pretty sure I will come back to Georgia one day. The wine is brilliant. I have never had that many good honeys there. Some of you knows that I've got bees, and so the honey in Georgia is spectacular, really, really good. So this on itself is a reason to come back. There are some nice people around as well.
Some.
Yeah,
okay, then. Yeah.
Can I ask a technical question?
Yeah.
Yes.
So you talked about Raspberry Pi, but I was wondering, like, what's the difference between Raspberry Pi and Arduino? Because I have some experience on working with Arduino. So which one would you recommend and why?
It depends on the context. A Raspberry Pi, obviously, is an energy waster. You need a lot of current to support a Pi, and you can't make a Raspberry Pi sleep properly. That's the one thing. Another thing is that the Arduino can be put to sleep, but not really efficiently. And I think I'll stop now and show you something which I work at the moment. This is something which I work on with the students. On the left, the green thing, you can see this is this small node which connects to the LoRa TTN. And the things to the right, it's just a display and some sensor. And this node, this small cube cell node, these can be programmed like an Arduino under the Arduino IDE. So when you have experience with an Arduino, you can work on these as well. And these can be put to sleep with nanoamps. So I would not recommend to you to buy another Arduino, because Arduino can't sleep properly. But I would recommend to you to buy something like that. In Switzerland, they are about, let's say, roughly 60 lari.
Wow,
each.
that's really cheap compared to the Arduino.
Yes. So and this has an LoRa completely. So even if you put away all this stuff here, if you just take the node, you can talk to the TTN with that, and you can play around and you can program it and you can look up if you can get contact, if you can send data, if you can receive data, and that's about 60 Lari. So I think
That's a very good deal.
That is affordable, yes. And to play around, one of these is plenty enough. And even you can use them directly because they have got a charging circuit on it where they can charge small lithium polymer accumulators, so that you could run this thing possibly on a single solar cell and a small lithium accumulator, and the system itself will care about the charging of the batteries. So that is, I think that is quite a good device. It is called Cube Cell from Heltech.
Okay.
If you
Thank
like, I
you
can.
for the recommendation.
Yes, I can give you a link to that in the chat if you like.
Yes, thank you.
Okay. Any more?
So when are you coming to Georgia? When we're still there and teach us.
He's silent now.
We're waiting for you, Mr. Heiser.
So you have now a link to the CubeCell things.
Thank you. Again, everyone, I will share everything like in an email after this event. If there's no more questions, I think we are done.
Not entirely. I would offer to give you the PowerPoint slides, but yes, as I have so many animations on it, it is not worth to let's say to publish it as a PDF, because the PDF would look completely cramped with rubbish. So I think it's okay if I send you the PowerPoint directly.
Yes, please.
Without not having it as a PDF. But you have to look at it as a PowerPoint. It doesn't make sense to look at it as a PDF.
PDF. Okay, I'll show. Is it on a PowerPoint or is it a Google slide?
No, it's PowerPoint.
It's PowerPoint. Okay. I'll share the file with others as well.
Yes.
When you send it.
Okay.
Yeah. Any more questions, guys? I'm checking Facebook as well because we're live on Facebook. And I think we're good. I think we covered everything. Do you have anything to add?
Me?
Yes.
Thank you for inviting me.
You for coming.
And I am open to remote teaching, but I think the concepts and the processes need to be established as well, because I think that is not on the agenda of normal schools at the moment to have let's say complete courses from people from abroad. I think that is not common yet.
We can make it common. We can be the first ones. We can be the pioneers.
Yeah, if possible, yes, no problem. Yeah,
I'm pretty sure they will welcome you anytime.
Yeah. Okay. So thank you so much, Ulrich, for giving us this lecture. I think we all missed you. So yeah, thank you so much.
So until the next cha-cha, or what?
Until the next cha-cha.
Good. Okay, so have a nice evening and goodbye.
You too. Bye-bye.
Thank you.
Thank you. Thank you, Misha. Thank you, Ulrich.